Hi. Hey there. Welcome. Let's get started. This video is going to be all about our viability review number 1, number 2, and number 3. They are nearly identical with the exception of one sentence. But don't worry about that sentence. It's pretty obvious which one it is. You can see in our timeline that it's broken into 3 parts. They are by no means equal in size. The first part comes out of component 1, the second part out of component 2, and the third part out of component 3, in which case you get a lot of time to work on it. In case you've forgotten how to navigate through the Canvas site, this is our course landing page. You can scroll down and find component 2 where element F is found along with its counterpart element E. Or you can scroll down to the bottom and find either of those 2 elements here. The one that we're focusing on today is in element F, as we're talking about the viability analysis. If you click on component 2, you can scroll down, find element F, consideration for design viability, click on that link, and it takes you right into here. This table has a lot of good information in it. Viability of the proposed solution reviews. Then there's the product development process flowchart, product lifecycle document, to harm or not to harm, which is a discussion, could your product fail, which is another discussion, and design it not to fail, which is the final discussion that you'll have. All 3 of those discussions pertain to your viability review analyses. Click on the viability of the proposed solution reviews. You can find all 3 of the viability reviews. The first one goes with your first proposal. The second one goes with your preliminary design review. And the third one goes with your critical design review. We're going to use viability review number 1 as our example. Introduction to develop or not to develop. That's literally the question you're trying to answer. Often, the decision not to develop a product is financial. Based on a thorough analysis, it is determined that the anticipated income from the product cannot support the anticipated cost of the development of that product. In other words, you ain't going to make any money on it because it costs too much to make. But let's say a financial analysis proves that you'll actually make a profit on this product. The question then becomes, should the product be made? But I'm telling you, this isn't an easy question to answer. This question is so difficult to answer because an engineer or a designer has an ethical responsibility to their client, their profession, and to society. So because of these responsibilities, the designer needs to consider what any and all potential consequences might be. What are the good or bad things that might happen resulting from the development of their product, and then compare the benefits of their product being developed to potential negative impacts it may have. It's a weighing game. Which one outweighs the other? Do the benefits outweigh the risks? Is continuing with the product development simply the right thing to do? The design, manufacture, packaging, distribution, and use of any new product will result in some form of consequences, both positive and negative. Those need to be looked at. These consequences are wide-ranging. For example, will the manufacture and distribution of the product consume non-renewable resources? Or will it produce some sort of pollution? How will the development of the product affect the workers who will produce or transport or even sell the product? Will it harm them? Will it give them superpowers? Will I get superpowers? I would totally pick the ability to fly. Totally. I don't know though. Being invisible? That'd be cool. That'd be really cool. You have to weigh things out. You have to decide, is this the right thing to do? What would happen if your product gets developed? What effect, intended or not, will the use of your product have on the consumer, the environment, on society? Will it change society? Will society be better or worse with your product in it? Will your product create jobs? That'd be awesome if it did. Can I have a job? I'd like your job. Can I have your job? I want to make toys. Can I make toys? Will you use abandoned facilities? Maybe you'll renovate an entire area of a downtown sector. How are you going to discard your waste materials? What kind of impact does that have? What kind of waste materials are you going to be creating?
The considerations mentioned above assume that the product is well designed and functions as intended, However, another important ethical responsibility of the designer is to ensure that the product is well designed and does not suffer unintended failure. What will happen if your product does not work as intended or suffers a catastrophic failure? Will the failure cause harm? It is important that the designer has the knowledge and expertise, or seeks out people with that knowledge and expertise to properly design the product to minimize the risk of failure. In this assignment, you will consider the consequences of your product design, compare the positive and negative impacts, and assess the ethical implication of continuing to develop your product.
Hey, resources. Look, it's the first two things on every assignment. Your ENB and some device connected to the internet. Now, hopefully you can find some trade journals, magazines, newspapers, and other materials, but we're all smart here. We know you're probably just going to go digging on the internet. Hey, I'm okay with that. As long as you find reputable places, you could probably find some of those trade journals or magazines. You might even be able to find something in an online newspaper. Who knows? There's two other sources here: product development process flowchart and product lifecycle documents. Let's take a look at them. Definitely utilize this as part of your project. This should definitely look familiar to you. You should have used this as part of your product lifecycle assessment. Pull from this what you can and what you feel like you should. You'll come back to this page quite a bit for element F. Procedure. So this next part's all about the inclusion of proposals and review dates. In other words, what it is that we're expecting. This is going to sound a lot like element E. Ready? Like many other tasks in EDD, this one is expected to be completed concurrently. Unlike most other assignments, this is one in which teams will revisit for each of the three proposals. Project proposal, PDR design review, critical design review, your final design proposal. So by the due date of each proposal, teams should add information they've gathered about the viability of their solution to their portfolio/technical report for element F. This is the section or document that is about your viability. Okay, so here's that sentence that's different in each one of the viability reviews. For the first viability review, the sentence says, by the due date of this first review, the team should be able to show the instructor the explanatory writing and organized collection of why or how their solution is viable. For the second viability review, this sentence says, by the due date of the second review, the team should be able to show the instructor the modifications they have made to their portfolio/technical writing that reflects further investigation, suggestions from their first proposal, and the inclusion of new discoveries about the viability of their solution. The final viability review says this: by the due date of this final review, the team should be able to show the instructor the final changes the team has made to their portfolio/technical writing that reflects all investigations, suggestions from their first two proposals, and the inclusion of all the discoveries about the viability of their solution. And really, if you looked over element E, you get it. You're going to have three of these. The intent is that for each one, you're showing me, the instructor, what it is that you're able to prove. Can you find the information? How do you document it? These are the important things. The intent is that you're going to be able to quickly take what you've written for this assignment and turn it into your technical writing, if you don't already have it that way when you turn this assignment in. Let's break down what to include for each review, the guts of this assignment. Depending on the problem and the solution presented during your proposals, your team will research and discuss many aspects of how and why your solution is viable. As your team progresses from one proposal to the next, new information will become relevant and important to include. These are the steps to follow as you work with your team. Step 1. So you need to consider the project proposal that your team is creating. You've been doing this leading up to the first viability review. You need to think of your design specifications. You need to consider the technical expertise and knowledge that is required to properly design your product. Has my team acquired the math, the science, and engineering knowledge necessary to properly design my product? Have we at least started to contact the experts so that we can gain necessary knowledge that we need to be able to obtain? Maybe we don't have everything we need for the design. Are we ill-equipped? We should contact some people. Uh-oh. This sentence looks slightly different for the second viability review, but it's basically the same thing. Same thing for the third viability review. Slightly different wording, but really it's the same. I'm going to give you a second to just read this short little paragraph here. Okay, so hopefully you've read it and you see that it's really kind of important. You understand what it means, what it says, and that we are expecting you to work concurrently with element E, and that we're not expecting you each step to have every single thing worked out. What we are expecting is that you have plans put in place, that you are considering these things. So let's take a look at this list below of some things you should consider as far as both elements E and F. These two things go hand in hand with each other in some ways. If you have a very physical object as opposed to, say, an app or some solution that isn't mechanical in nature, then that physical object will likely have to be subjected to some sort of loads. How will loads be transferred from the environment around it to your product? And how will those loads be transferred within your product? POE, CEA, very important classes when it comes to being able to understand the math, science, technology, and engineering involved in these calculations. And they will help determine whether or not your product is viable. Will these loads be static, which means they're unchanging, they're constant? Or will they be dynamic, which means they're probably changing a lot? How do you calculate the loads? Does anybody in your team know how? And if not, who do you contact? Don't contact a teacher. Find out from your mentors, your experts. Do some research. You might need to take some extra steps here. What about the components of your product? Will they be able to withstand the magnitude of these loads? Also, what about materials? Will your choice of materials withstand the test of time? Will the density or weight of the materials adversely affect your design? Will mechanical properties of your materials provide sufficient strength, stiffness, or abrasion resistance? Are your materials good enough for your product? Do you need to rethink this? Have you thought about it yet? And if so, what documentation do you have to show that it is either going in the right direction at the beginning, you have highly considered it in the middle, you have proven it by the end? Will the materials be able to withstand repetitive loads without failure? If not, what good is it? How's it going to operate well within the range of temperatures that my product's going to be subjected to? How's this thing going to react to sunlight? How's it going to react to rain? How's it going to react to dust storm? What if I drop it? Then there's mechanical engineering. Does your design require an input for heat or mechanical power? Are there moving parts in your design? What simple machines are going to be used in your design? Do you remember the 6 simple machines? Will all the components of your product interact effectively? Will the loads be efficiently transferred from part to part within your product? Do the parts move at an ideal speed? Is that important? Perhaps it is. Perhaps it's not. Even if they're not mechanical, and say you're making an app of some type, you need to consider how functional is that app. You could get into looking over the energy, the chemical or bioengineering aspect of it, or the electrical engineering aspect of it. These are just some of the things you should look at. Number 2, consider and reconsider the following ethical questions and revise your design as necessary. Have you researched laws, codes, and regulations that could potentially impact your design? When you think about it, do you feel like your team has met its ethical responsibility for technical expertise related to the design of your product? If not, you need to perform additional research right now. Number 3, create or modify as needed a graphic to document your product's anticipated life cycle. Research what it's going to take for your product to go from raw material to the end of its life. Maybe even what happens to it if it gets reused or recycled. Will that happen with your product? Is that something you even need to consider? Be sure you detail each phase with information specific to your product. I highly suggest you read through these examples. It's pretty similar to the product lifecycle assessment activity you did at the beginning of the year. 4Zs. Consider and reconsider the consequences of the development of your product at each phase in its life cycle to people, the environment, and society. When you're considering or reconsidering these consequences for people, think of designers, users, non-users, employees of the manufacturers, distributors, sellers, and anyone else that you can think of that this might impact. When considering it for the environment, include the following. The use of non-renewable natural resources. Think of the potential release of toxins, waste, or pollution. Consider whether or not there has to be the creation of unsightly facilities or really loud noise pollution to make your product. Is there an effect on animals or plants? You might even want to consider, is there undue light pollution? When you're considering society, consider this. The social implications and how your product could change the way society functions. Or will there be laws that have to be made? Think about seatbelts. People didn't wear them. We had to make laws so that people were required to stay safe in their car. I don't want to wear a seatbelt. It keeps me from moving around my car while I'm driving. Really? Yeah, I don't want to be restricted to just the driver's seat. Really? Yeah, what? Laws had to be made. Last one, number 5. Compose and modify an ethical justification for the further development of your product by describing why and how the benefits outweigh the negative impacts. Right, so I would super highly suggest to you, if you haven't been doing it already, look at those scored examples. Probably going to help you out somewhat. I'm going to read this sentence to you. By the due date for each review, your team should have documented the viability of your solution based on the information above and be prepared to review it with me, your instructor. For each review, continue to modify this document to include new information and reconsideration of the viability claims already made. Don't forget to work on the other concurrent assignments and be prepared for your proposal coming up. This review is worth 20 points. When you turn it in, submit a website URL or upload a file. Well, that brings us to the end. Viability of the proposed solution reviews. 3 of them. Let me know if you have questions, but as always, have a great night. See you next time.